So the surge should be sent to the ground. Therefore, the lower rod will be earthed and the upper rod is connected to the equipment which is to be protected. Okay, so we have seen its operation in the last class. Okay, so actually I might have continued this topic in the the next day itself. Because of Wi-Fi issue in the college, we couldn't continue the topic. Otherwise it might have been better, because there might have been continuity. Okay, now it has been okay a while. Okay, so leave it. So next type horn gap lightning arrestor. Okay, so our the main purpose of using lightning arrestor is to seize the surges or the over voltages caused in the power system. Okay, so we want to suppress the over voltages in the power system by using these lightning arrestors. Okay, so here in the case of horn gap lightning arrestor, if you see, I have written here two apparatus to be protected. Means this is let us assume there is an apparatus connected here. Any equipment of the power system is placed here. Of course, it is not shown here anything. Simply I have written something. Okay, so here the apparatus to be protected is there. Okay, so here we are going to use horn shaped electrodes. Two horn shaped electrodes are there. Okay, so these horn shaped electrodes will be placed on a porcelain, okay, insulating material, such as for example porcelain. Okay, so these horn shaped electrodes will be having small gap at the lower end. Okay, these horn shaped electrodes will have smaller air gap between at the lower end. As we move upward, the gap between these two electrodes will be gradually increasing. Okay, the gap between these two electrodes will be gradually increasing. I hope you remember, if you have attended one of my class in which I was discussing about different types of switches. In that case also I discussed about the horn shaped, okay, switch. Okay, so here in this horn shaped lightning arrestor, we are having horn shaped electrodes. Okay, so the gap between these horn shaped electrodes at the bottom end will be less when compared to the gap between the horn shaped electrodes at the upper end. Okay, they are placed on a porcelain insulator, and one end of this horn shaped electrodes is connected to the apparatus through a choke and a resistor. Another end of this horn shaped electrodes is connected to the earth. Okay, so in simple words, if you want me to say, one electrode is earth and another electrode is connected to the apparatus with the through a choke and a resistor. So the purpose of the resistor here is to limit the current. Okay, in order to limit the transient currents, okay, to which may flow into the apparatus and which may damage the insulation of the apparatus. Okay, so in order to limit the surge currents or transient currents, this resistor is connected here. Okay, and the purpose of this choke is to limit the transient frequencies. Okay, under normal operating condition, it will offer low reactance. Okay, at normal frequency, under normal operating condition for normal frequencies, and this choke will offer low reactance. So if any transients occur, if any over voltage occurs in the system, which may this over voltage may travel towards this apparatus which is to be protected here. Okay, so somewhere in this in the power system, if over voltage occurs, that over voltage may travel towards this equipment which is to be protected. Okay, so this choke, okay, it will offer low reactance under normal frequency of the system voltage, and it will offer high reactance for transient frequencies. Okay, if over voltage occurs, transients may flow towards the apparatus to be protected. Okay, the transients may flow towards the apparatus which are to be protected. This is, let us assume this is one apparatus. Okay, towards this apparatus we want to protect this apparatus. Okay, so if transients are traveling towards this apparatus, then this choke will offer high reactance. So this resistance will limit the current, of course. Okay, but if this resistance fail to limit the current. Okay, of course it will try to, the purpose of this resistor is to limit the fault currents. Okay, as well as this choke will also limit the transients or voltages. Okay, so the high frequency transients, okay, will travel, which are traveling because of the fault at some location in the power system toward this apparatus. Okay, so the purpose of resistor is to limit the fault current. The purpose of the choke is to limit the transient voltage by offering high reactance during over voltage condition. Okay, so these are the purposes of R and L here in this. Now let us consider a normal operating condition. Okay, so under normal operating condition, the current that is flowing through this system, power system, or through this apparatus, okay, will not cause any discharge of electrons between these two electrodes. Means it will not cause any arc to struck between these two electrodes. Okay, so there will not be any arc, means the normal current won't be able to strike any arc between these two electrodes of this resistor. Okay, so under over voltage condition, if over voltage occurs due to fault, okay, it may be due to lightning. Okay, one of the reason I'm telling, it may be due to lightning. If over voltage occurs, then an arc is struck between, means there will be discharge of electrons from one electrode to another electrode. That is, an arc is struck between A and B. Okay, between A and B electrode. Let us assume this electrode is A, this electrode is B. So in between these two electrodes, an arc is struck. Now, when arc is struck, there is discharge of electrons between these two electrodes. So when there is discharge of electrons between these two electrodes, what happens? When electrons are moving, definitely they will emit, they will be colliding with each another, and they will be emitting energy. Okay, and and what will happen? The air which is surrounding here in between across this arc. So arc is struck at point 1. Let us assume. Okay, just for understanding the concept, this one is written here. So an arc is struck. Okay, and because of the electrons that are there in this arc. Okay, so the air surrounding the arc will be heated up. Okay, so when air surrounding the arc is heated up due to the hot air surrounding the arc, as well as due to magnetic effect, this arc will gradually start to move upwards. It is similar to your hot air balloon. Okay, so if you know about the hot air balloon, what is done in the hot air balloon? Within that balloon, the air is heated up. When air gets heated up, it gets lighter, and the hot air balloon starts to move upwards. Okay, so the same process occurs here. Okay, so due to the air that is heated up surrounding the arc, and due to the magnetic effect, the arc will gradually start to move upwards. So as the arc gradually starts to move upwards from point 1 to point 2, point 2 to point 3, what will happen? The length of the arc is gradually increasing. As the length of the arc is gradually increasing, similar to your elaster, I think I have explained it already in your class. Okay, when you expand an elaster, okay, so the elaster will gradually, when the elaster is gradually expanding, the cross section of the elaster will gradually reduce. Means the density of the elaster, the cross sectional density of the elaster is gradually reducing. So as the length of the arc is increasing, the density of electrons is gradually decreasing. So as it is moving from point 1 to point 2, the number of electrons coming in contact with the air becomes more. So air is taking away the heat of the arc. Okay, as it moves from point 2 to point 3, the length of arc is further increased. More number of electrons of the arc are in contact with the air. Okay, so when more number of electrons are in contact with the air, okay, air is taking away most of the heat from the arc. So the arc won't be able to maintain the discharge of electrons, won't be able to maintain contact between electrode A and electron B, and the arc will cease. Okay, so the arc will extinguish at point 3. Why? Because the cross section of the electrons in this arc has reduced. Okay, the cross section of the electrons has reduced, mean the density of electrons at position 3 has reduced a lot. Okay, and the arc won't be able to maintain. Okay, so whatever So you can see here I have written at some position of arc, perhaps position 3. The distance may be too large for the voltage to maintain the arc. Okay. So voltage means the density has reduced to very low value. So whatever voltage is maybe over voltage is there which has caused the arc to stuck between the electrons, it won't be able to maintain the arc and the arc will extinguish. Okay. So arc will extinguish at point 3. Okay. So the excess charge on the line is thus conducted through the resistor to the ground. So what will happen? It will extinguish and the arc will, whatever arc is there, it will cease towards the earth. This is what happens. I have already varied the slide. Okay. Why is it happening? Yeah. For you people, the slide is not varying. Okay, 1 minute. There is some issue, it seems. I'm varying the slide, but it is not varying for you. Transmission. This is the slide that you are able to see. I have already varied the slide. Yeah, now it is varying. Okay, now it is varying. Now I will vary. Okay, this is no. Yeah, this is what I wanted to show. So when at point 3, what will happen is the arc will extinguish the excess current, whatever is there, the arc current we can say, that will go towards the earth, that will be ceased. Okay, so whatever excess current is there across it, the arc will extinguish and the excess current will flow towards the earth. Okay, okay, that's it. That's what I wanted to tell. Okay, so so the excess charge on the line is thus conducted through the resistor to the ground. Okay, and it is, one thing is that about this lightning arrestor, horn gap lightning arrestor, is that it is not reliable. It is generally used as backup protection. Okay, generally if the main protection fails, then we will prefer this type of protection. So it's not the primary protection, it is a backup protection. So one more lightning arrestor, next one is multi-gap lightning arrestor. Okay, so in the case of multi-gap lightning arrestor, so here we are going to use some metallic cylinders which are made up of zinc alloy. Okay, so metallic cylinders are used here in this multi-gap lightning arrestor. Okay, so they are made up of zinc alloy. They are insulated from each other. Okay, each metallic cylinder is insulated from each other, and these cylinders are separated by small air gaps. Okay. Okay. So if you see, you can see here there are metallic cylinders here. You can see the cross-sectional view of these metallic cylinders in this diagram. Okay, and if you see terminal A, terminal B, and terminal C is there. Okay, of course I might have given notation to other two cylinders also. Okay, so these are the series gaps. Okay, and one end of this cylinder, one cylinder extreme left or right, whatever it is. So one of the cylinder is connected to the line which is to be protected, and the first cylinder is connected to the line that is to be protected, and the last cylinder is connected to the ground through a series resistance. Okay, so through a series resistance, the last cylinder is connected to ground, and the first cylinder is connected to the line which is to be protected. Okay. Now it is observed that the series resistance, it has to limit the power arc. Okay, so it means under normal operating condition, if there is any leakage in the line, okay, so that is to be seized to ground. That should travel through the series resistor to the ground. But it is observed that this series resistor is decreasing the degree of protection against the traveling waves. Hence, we are using a shunt resistor. Means across B and C, shunt resistor is connected. Why? Because the degree of protection against traveling waves is reduced by this series resistor. Means it is unable to limit the leakage current if it is there in the system even under normal operating condition for the system voltage. So whenever I say system voltage, that means it is a normal voltage of the line or the equipment which is to be protected. Okay, so under normal operating condition, if any leakage is there, okay, so even a small leakage, see, nothing is ideal. Okay, nothing is ideal, nothing can be perfect. Okay, so even in our laboratories, we give 220 volt supply sometimes. Okay, for the DC supply. Okay, so it was, for example, 230 volts supply for AC. So, but when you turn on the meter, or when you give the supply, there will be a display in our laboratory, the boards, if you have observed while doing the experiment, it will not show, the pointer will not reach exactly to 230 volts, or if it is 220 volts, it will not reach to exactly 220 volts, maybe by bit less or slightly up or down. The pointer will be either above 220 or less than 220 sometimes. Okay, so nothing is ideal. Okay, so sometimes and which is means parallax error, slight percentage of parallax error is always acceptable. Okay, slight leakage is also acceptable. It doesn't, if it is not causing much damage to the system, then it is acceptable. Okay, so here if even under normal operating condition, if there is any leakage of current, this series resistor should limit it. Okay, the series resistor should limit. Means during normal power, if there is any leakage means, of course, these insulators are, these cylinders are insulated from each other. They are series cylinders. Okay, so they are insulated from each other. Of course, means there is an sufficient gap between these cylinders. Okay, so when there is sufficient gap, there is no conduction. There will not be any conduction. But if conduction has to occur, there must be any leakage. There must be leakage from one rod to another rod to another, and so on. Okay, so if there is any leakage under normal operating condition, this resistance has to limit that leakage. Okay, so but it is observed that if there are any traveling waves under normal operating condition, this series resistance is unable to limit that current. Therefore, a shunt resistor is connected between the cylinder B and C. Okay, so across B and C. So these two resistors together will limit the leakage of current under normal operating condition. Now, under normal operating condition, there will not be any arc struck across these cylinders. Okay, across these cylinders, no arc will be struck. Okay, under normal operating condition. Okay, so we need not worry. So if more voltage occurs in the line which is to be protected, okay, this is the line which is to be protected. If any over voltage occurs, then the transients will start to travel through this arrestor, and okay, and arc is struck between A and B. Okay, an arc is struck between cylinder A and B. Okay, of course there is one more cylinder is there. Okay, I can say the arc is struck between these two cylinders, as well as arc will be struck between these two cylinders. So instead of using the instead of telling that, I am directly telling arc is struck between A and B. And if the over voltage is severe, the arc will strike between B and C. Instead of traveling through shunt resistor, it will directly travel from B to C, breaking the insulation between B and C cylinders. Okay, so this whatever arc that is struck here, okay, and this resistance, of course, it won't be able to limit that arc or voltage. Therefore, that over voltage travel through the earth. Okay, so this over voltage will travel to the since it is this lighting resistor is grounded at this terminal, it will travel to the earth. As soon as the over voltage is over, it has been seized, or it has spanned this gap and traveled to the earth, or it is grounded. What will happen is, okay, when the over voltage, okay, when the transients have spanned these insulated cylinders, okay, and they have been traveling, means they will just span this gap and go to the earth. Okay, when the over voltage is over, okay, so when the voltage in the system is unable to maintain the arc between the electrode A to C. Okay, so when arc is means the whatever arc is there, okay, it has been I'm unable to get the words. Okay, wait. Simply they have used here in the text, they have used simply when the surge is over, when the arc goes out. Okay, so it's the best word. Okay, when the arc goes out to the ground, what will happen is this shunt resistor and the series resistor will limit the together, they will limit the normal current to causing any power arc across A and B terminals. Okay, so it won't cause any power arc between A and B terminals. This shunt and series resistor together, they will limit the overvoltage. Babu, roll number 12, respected roll number 12. క్లాస్ లో ఉన్నారా లేరా మీరు? ఒక్కసారి
నెట్వర్క్ ప్రాబ్లం వల్ల కట్ అయిపోయింది మ్యామ్.
కట్ అవడం కాదు మా, మీరు ఎందుకు అటెండ్ చేశారు? ఒక్కసారి నా చెవులు బర్స్ట్ అయినట్టు అయింది సడన్ గా. మీరు దయచేసి మీ మ్యూట్ చేసి పెట్టుకోండి అందరూ. నెట్వర్క్ కి మ్యూట్ చేయడానికి సంబంధం ఏంటి? సిగ్నల్ కనెక్షన్ గురించి మాట్లాడలేదు. ఒకసారిగా సడన్ గా ఒక ఎయిర్ బ్లో అయినట్టు నా చెవులు రెండిట్లో. ఓకే, when the surge is over, okay, so definitely the normal current, the power current means normal supply current, it won't be able to maintain the arc between terminal A to B or C. Okay, so the whatever normal current is there, power supply current, system voltage current won't be able to maintain the arc. Therefore this shunt resistor and series resistor will offer enough resistance to limit the normal current to travel to the ground. Okay, and this is also actually this means this system, these resistors, they can be employed for the systems whose voltage does not exceed 33 kilovolts, means the systems which operate at lower voltage of 33 kilovolts. Okay, so this is about the operation of the multi-gap lightning arrestor. Okay, so if anybody wants me to repeat, I can repeat the horn gap and multi-gap lightning arrestor. Do you want me to repeat? You just type R, Amma. Otherwise, I'll proceed to the next lightning arrestor. Okay, I don't know. I tried my level best to reach you people. I don't know whether you have followed or not. So in the classroom, we will be observing your heads, nodding heads. That's why we will get some assurance that some of you at least might have followed the class. Okay, so కొంచెం మీరు అందరూ మీ మైక్స్ అన్మ్యూట్ చేయకండి. ఓకే, ఎందుకంటే ఇందాక సంథింగ్ ఓకే ఇట్ వాస్ నాట్ గుడ్. ఓకే, వాట్ ఎవర్ ఇట్ ఈస్, రిపీట్ అమ్మా. సో తరుణ్ వాంట్స్ మీ టు రిపీట్, దట్స్ వై ఐఎమ్ రిపీటింగ్. యూ వాంట్ మీ టు రిపీట్ మల్టీ గ్యాప్ ఆర్ రాడ్ గ్యాప్? తరుణ్, number 2 or number 3? Multi-gap. Okay, so once again I'm repeating multi-gap lightning arrestor. So in the case of multi-gap lightning arrestor, Amma, we will be having metallic cylinders. Okay, so which are made up of zinc alloys. Okay, these metallic cylinders are kept in series with air gap between them. Okay, means they are insulated from which air gap is there between, if this in between this cylinder and this cylinder, if air gap is there, means what? It is insulated from each other. Okay, so all these metallic cylinders which are placed in series, they are insulated from each other, and one of the cylinder, extreme left or right, whatever it is, okay, one of the cylinder is connected to the line which is to be protected, and the another end cylinder, one end cylinder is connected to the line that is to be protected, another end cylinder is grounded through a series resistance. Okay, another end cylinder is grounded through a series resistance. So under normal voltage condition, if there is any leakage of current from the line, okay, if there is any leakage of current, then it may cause leakage of electrons from one cylinder to another cylinder and so on to C, terminal C, or the electrode C. Okay, or we can say metallic cylinder C. Okay, there may be discharge of electrons during normal operating condition. Okay, I'm talking about normal operating condition. If there is any leakage of current, because nothing is ideal. Okay, because nothing is ideal, there may be the leakage of current from this line towards this last cylinder. There may be discharge of, you can say leakage of current means there is discharge of electrons means arc is struck. Okay, so it is, of course it is not severe because it is normal operating condition. Normal system voltage will be there in this line. Okay, so it will not cause any damage to any equipment here, but there may be discharge of electrons from terminal, from cylinder A to cylinder C, and this resistance may not be able to limit that current. Okay, there should not be any leakage of current from the line towards the ground under normal operating condition. Okay, so this resistance won't be able to limit that current. Therefore, a shunt resistor is connected between cylinder B and cylinder C. Okay, so you call this BC gap as shunt gap, AB gap as series gap. Okay, so that's why this shunt resistor is connected here. Now, under normal operating condition, these two, the shunt resistance and series resistance together, they will not allow the leakage of, because so even if an arc is struck between A to B, the leakage current under normal operating condition has to travel through the shunt resistor, then it has to travel through the series resistor to reach the ground. Okay, but together these two resistances will limit the leakage of current under normal operating condition. Okay, now under abnormal condition, okay, means no arc will be struck. Okay, no arc will be struck under normal operating condition between these insulated series connected cylinders. Okay, now under abnormal condition, if overvoltage occurs, okay, in the line, okay, within the line or somewhere in the system, okay, which is connected to the line, okay, so this overvoltage will definitely cause, okay, fault current to flow into the arrestor. Okay, this fault current will definitely cause arc to strike between the AB terminals, even though they are insulated. Okay, these two cylinders, AB cylinders, even though they are insulated, definitely this heavy current, heavy fault current will cause arc to strike between AB series gap. It will span the series gap and arc is struck between AB cylinders, and again the arc will also strike between BC cylinders instead of traveling through shunt resistor. Okay, instead of traveling through shunt, I mean it is so severe. You know, short circuit, under short circuit condition, okay, what will happen? You know that. Okay, so in your circuits you might have learned. Okay, you might have solved some problems about on short circuit condition. Okay, so arc is struck between A to C. Okay, and this series resistance anyhow it was unable to even limit the normal supply voltage leakage current. Okay, it won't be able to definitely limit this fault current, the arc which is struck due to fault current, and the arc will travel through this. Of course, it won't. This resistance will not be able to limit that arc current. Therefore, it will be grounded. Means the arc current will cease to ground. Okay. So our main aim of this lighting resistors is we want to run out the arc from the air gap. It is just send it to the ground. Okay. So we want to send the arc to the ground. Okay, so whatever arc that is struck, the leakage of electrons between these gaps must be sent it to the ground. So the arc will be sent to the ground. Okay, so as the arc is ceasing to the ground, it will not, of course, it will not return back. It will be ceases. It just goes to the ground. Okay, so what will happen is, as soon as the arc is over, okay, this shunt resistance and the series resistance will offer enough resistance. Okay, as soon as arc is out. Okay, arc just goes out, it will offer enough resistance under normal operating condition to limit the normal supply current to not to travel, not to cause any arc across these cylinders, insulated cylinders. Okay, one thing if you remember, I don't know, at the beginning of this unit, I have told you that whenever overvoltage occur, they will occur for very short duration of time and they will cause severe damage. Okay, so they won't persist for longer duration of time. Over voltages will not persist in the system for longer duration of time. They will persist for very short duration of time, and within that short duration of time, they will damage the equipment. Okay, so within that period of time, within that short period of time, these lighting resistors must do their performance. Means they should do their operation. Okay, so as soon as the arc is ceased to ground,
Okay, the normal line voltage, whatever is there in the system, it won't be able to cause any arc. Why? Because the shunt resistance and series resistance will try to limit the normal current in the system or in the line. Okay, so they will not allow arc to restrike. Okay, so I will discuss about why arc, once the arc is over, why the arc will restrike in the system. What are the conditions for the arc to restrike in the next unit, not in this unit. Okay, so in the next unit I will discuss about it. Okay, I hope Tarun have understood. Tarun, is it okay or you want me to repeat? Tarun has to reply. Okay, okay Tarun, we will go to the next one. Okay, that is expulsion type lightning arrestor. Okay, so in the expulsion type lightning arrestor, if you see here, so this is the line that is to be protected. Okay, so you can see here in this diagram, this is the line that is to be protected, and in this lightning arrestor we are going to have right angle bent two rods, which are at the inner ends of these rods are fixed with electrodes. Okay, so the gap between these two electrodes, A and A dash, is known as rod gap. Okay, so and this lightning arrestor is also known as protector tube. Okay, this lightning arrestor is also known as protector tube. Okay, it has two air gaps actually. One air gap, just now I have explained about it, that is, it is made up of two rods. Okay, with an air gap. Another rod gap is in between another two electrodes which are placed in a fiber tube. You can see a fiber tube here. This is a fiber tube. Okay, so this is the air gap here in between two electrodes. This is one electrode. This white portion, you can see upper one is one electrode. This lower white portion, this is one electrode. So here two electrodes are there in between. Gap is there, air gap is there. These two electrodes are placed with some air gap in a fiber tube. And one more thing is the lower electrode is hollow. Okay, the lower electrode is hollow and it is earthed. The lower electrode is hollow and it is earthed. Okay. Now, usually in practice, this is just to understand the concept, this diagram. In practice, it will be like this. This is the transmission tower. Okay, this is the transmission tower. So, you know, these are the, what to say, arm of the tower, on which insulators are placed. At the end of the arm, insulators are placed, and below the insulators, conductor, transmission line. This is our transmission line. Conductor is placed. Below that, this protector tube is placed. Means this expulsion type lightning arrestor is placed below the conductor. Okay, this conductor is nothing but this line. Okay, this line is this conductor. Okay, I hope you are able to follow. And if you see, I have told you that, okay, I have told you that this protector tube, the lower electrode is grounded. Actually, the tower is grounded. It is connected to the tower, and the tower is grounded. In practice, this is the actual connection diagram. But not explain the concept, we are assuming that the lower electrode, hollow electrode, is earthed here. Okay, now under normal operating condition, the current, when a supply voltage is there in the line, the current in the line will not cause any arc to strike. Of course, the line current may flow through this electrode or rod A, okay, and it will not cause any arc to strike between A and A dash. Okay, so these two A and A dash are insulated from each other. Okay, so no current will flow through A dash because the upper electrode of this fiber tube is connected to A dash, to this rod. The lower electrode, hollow electrode, is connected to earth. Okay, so we want, our main aim is we want to seize the arc to the ground. That's all. Okay, so under normal operating condition, no arc is struck between A and A dash. So whenever we discuss about any equipment in this subject, you have to consider two conditions. One is normal operating condition. Another condition is abnormal condition. Okay, so almost for each and every equipment, you have to consider two conditions, and you have to explain about those two conditions for each and every equipment, almost in every topic in this unit, not only in this unit, in this subject. Okay, so now when abnormal condition occurs, means when over voltage occurs in this line, that over voltage means the fault current due to over voltage is to be ceased to ground. So because of that over voltage, the fault current will cause arc to strike between A and A dash. This arc will span through A dash, through gap A dash, and it will pass through this lower electrode of this, and it will go to the electrode, this electrode, okay, upper electrode of this fiber tube, and an arc is struck between this these two electrodes within the fiber tube. Okay, in between this upper electrode and in between the hollow electrode, an arc is struck here. So whenever over voltage occurs in the line, the fault current will cause arc to strike between A dash. The arc will span this air gap. Okay, and it will span this air gap A dash, and another arc which will, the fault current will travel through this rod to the electrode, and the arc is struck between these two electrodes within the fiber tube. So you know the property of the arc. So you people, of course, you don't know the property of the arc. We will discuss about it in the next unit. Okay, so arc will heat up the discharge of electrons. I have already told you in simple words that arc is nothing but discharge of electrons. So the electrons will emit heat energy. Okay, so actually arc is purely resistive in nature. Okay, so whatever arc is struck across the rod gaps or anywhere, okay, it will be purely resistive in nature. You know, a resistive element property dissipates energy in the form of heat. I hope you people know that. So arc will dissipate energy in the form of heat here. So what will happen is some of the fiber material will be evaporated. Okay, so this tube is made up of fiber material. So some of the fiber material of this tube will be evaporated, and the evaporated fiber material is nothing but the neutral gas. When the fiber material of this tube is evaporated, neutral gas is produced at high pressure. Okay, as the neutral gas is produced, the pressure producing within this gap between the electrodes, the pressure within this gap is gradually increasing. Okay, so this high pressure neutral gas will take away this arc with it, with the pressure is gradually developing within this gap, and since the lower electrode is hollow, the high pressure neutral gas will take away the heat of the arc, and it will travel through this lower electrode to the ground. Okay, so it is such a high pressure neutral gas, means the pressure is so high that the arc will be immediately extinguished. Okay, because of the high pressure neutral gas. Okay, the pressure, you know, when pressure develops gradually in somewhere, okay, it has to be, means it will try to relieve itself by some or the other means. So there is a hollow tube here. Definitely the neutral gas will try to travel through it, and it will take away the heat of the arc, and arc is extinguished. Okay, and once the arc is extinguished, arc will not restrike in this in this lighting arrestor. Okay, so this deionizing effect means arc is extinguished, means and the air was ionized within the, means the arc was struck between the gap, isn't it? So when arc is extinguished, we will call it as deionizing effect. Is generally so strong that arc goes out at current zero and it will not reach re-established. So arc will not restrike within the gap. Okay, so these type of expulsion type lightning arrestors are very expensive, but they can be easily, I'm sorry, they are not expensive. I'm telling in the reverse way. So they are not much expensive, and they can be easily installed. Okay, so one drawback of this lightning arrestor is that after each operation, some of the fiber material is evaporated here. Okay, so it can perform only limited number of operations. Okay, so it has very poor volt ampere characteristics, so it is not suitable for protecting expensive equipments. Okay, so this type of lighting arrestor is not used for protecting against expensive equipments. It is used only for protecting low expensive equipments. Okay, of course, it is also not expensive. It itself is not expensive. Okay, so if you want me to repeat, I will repeat, or I will take attendance. Anybody? If you want me to repeat, just inform me. I will repeat. Anybody wants me to repeat about expulsion type lightning arrestor? I hope I was able to reach you. Okay, it will be having two rod gaps. Okay, initially due to over voltage, arc is struck between A dash. Okay, that arc will span A dash and it will go through the upper electrode into the fiber tube, and arc is struck between the hollow electrode and the upper electrode within the fiber tube. Due to the resistive nature of the arc, the fiber tube material, some of the fiber tube material gets vaporized. Okay, and high pressure is developed within that air gap between within the fiber tube, and this high pressure neutral gas will take away the heat of the arc through the hollow electrode. It just goes out and no arc is struck, is restruck. Okay, no arc is restruck between the gap within the fiber tube. Okay, and hence the arc is extinguished. Okay.